Alright, so now for fun, all we're going to do is justify the formula for area of the circle. Alright, this is just one way to think about it. Is it the best way? I'm not sure, but it's going to help you visualize how we know the area for the circle. So we're going to divide it up into 16 parts. Alright, so there's 16 pizza slices right here. Alright, what does each shape look similar to? Well, we're not going to say pizza slice, we're going to say it's similar to a triangle. Alright, it's not exactly a triangle, that's why we said similar. And what's the height of each shape? So realize, like, if we focus on this pizza slice right here, it's like, what's the height of it? Would be this right here, which is just the radius. We'll actually write it down, radius. Put R in parentheses. And what's the base of each triangle? So, looking at this now, what would be the base? What's the circumference divided by 16? So whatever the circumference is, it's just a 16th of that. Alright, so we'll just write C over 16. Alright, and then what we did right here was we unfolded the triangles. Alright, so again, right here, we can even say, well, radius C divided by 16. That'd be true for all of them. Alright, now let's find just one area of the triangle. Remember, area for a triangle, A sub t, is 1/2 base times height. Alright, so 1/2, the base is C16, and the height was R. Alright, so what's the base of each triangle? What's the height? Plug them into the formula. We get 1 times C times R, which is circumference times R over 32. Alright. And then what's the total area of all the triangles together? Alright, so the area of the circle is going to be 16. There's 16 times of them. Circumference R over 32. Which we're going to have 16 times CR over 32. So we have circumference times radius over 32. Now, something else we have to realize though, but ... circumference of a circle equals 2 pi r. Oops, I meant to write that as C over 2. We're rewinding really fast. 16 over 32 becomes 1/2. Alright, but then we don't need to write that 1/2 right there. So then plugging in that for C, we get 2 pi r times r over 2, which just becomes pi r squared. Alright, will you be asked to do this for a test? Well, the answer is actually yes. On the air test, we saw a question like this one. So that's why we talked about a little quirky, a little goofy. But really what it's just saying is that the area of a circle, really the punchline, we can derive the formula for a circle by making a lot. How many do we have to? A lot of triangles. Alright, if you can just make smaller and smaller triangles into a circle, you get closer and closer to the actual formula for area of a circle. And how many do we need to do? A lot. It's infinitely many. Alright, the more, the smaller, the better. Alright, so that's really just kind of what this punchline was. And to estimate the area of a circle, Henry divides the circle into a radius of r into n triangles. Alright, so all I'm reading is that problem above. So these are radius makes it into a triangle. There's n triangles. Alright, n just means there's a some number. Alright, and again, the bigger the number is, the better. As shown, as he uses the expression h over 2 plus base 1 plus base 2 plus base 3 plus so on and so forth all the way to base n. Alright? So really what he's saying is this is a similar thing to what we were doing above. We have 1/2 base times height. He says the height is the same as the radius, and then there's just a lot of circles. Above it was all the way up to 16. We're going to say base sub n because it's just some number. Alright? And he does this to represent the bases of each triangle and h to represent the height of each triangle. Henry claims that the more triangles the circle is divided to, the closer the estimation of the area of the actual area. Which statement about Harry's claim is accurate? His claim is accurate. First off, it is an accurate claim. We were just talking about it. Alright. So his claim is inaccurate. We can already exit out those. So if we can even just have a baseline understanding of what's going on, we can eliminate two answers. His claim is accurate because as n gets larger, the value of h gets closer to the value of r, and the value of base sub 1 plus base sub 2 plus base sub n approaches 2 pi r. That seems pretty good. Alright. And his claim is accurate because as n gets larger, h. Remember, h is the radius, right? H is the radius. So look right here. H gets closer to the value of r. That seems pretty legit. This one he's saying h gets closer to the value of 2r, which is the diameter. That does not seem good. Alright? Because nowhere above is it talking about the diameter. So the answer is actually going to be this one right here. Alright? So stay tuned.